A huge thanks to my Patreon supporters for making this episode possible. If you haven't done so already, make sure to check out my newly founded shop xdddd. There I'm selling handcrafted products like these sexy looking tensegrity tables, as well as handcrafted headphone stands and toys, etc. New wood types and old ones that have been sold out are available now once again, so check out link in the description, xdddd, and support the channel this way. Thank you very much. Last time around I calculated, you could say, rather or not, I don't know, exact value for the sine of 1 degree, and many people weren't really satisfied with it because, well, the answer was rather complex, if you know what I mean, and this is why I decided to create a video on something constructible for once. Constructible means, so for example for the angle of 3 degrees, that we can express the cosine of this constructible angle using radicals. Okay, for example 1 over square root of 2 for the cosine of 45 degrees. This is what we are going to need later. Shh, don't tell anyone. So yeah, this is what we are going to take a look at today, and I hope you are going to enjoy this video, but we better get started because we are going to be nutty busy today. Speaking of nuts, have I told you about our newest sponsor, Daily Peanut, already? It's your news source for world news, daily news, delivered to your doorstep for completely free in a satirical kind of fashion. So if you love the content here on this channel, the sense of humor that I'm doing here basically, then you are most certainly also going to love Daily Peanut. It really doesn't matter in which topics you're interested in, be it culture, world news, political news, traveling and leisure. Daily Peanut definitely has you covered. When I first visited their site, I thought it was really funny that you can subscribe to their newsletter to sound marginally more intelligent, which was really funny in my opinion. And yeah, if you also want to sound a bit more intelligent by reading the news with a slightly satirical undertone, then definitely make sure to subscribe to their newsletter, aka Daily Mail. And if you're going to unfold their daily newspaper, you're going to notice that they basically categorize their newspaper into different categories, like the peanut gallery, seasoned nuts, which is going to give you some nice and spicy quotes from different kind of people. Then, in a nutshell, must reads, for example, news from America and all around the world. And like mentioned before, if you're interested in daily news, just what's going on in the world, then definitely make sure to give Daily Peanut a shot. So if this feels like it's something for you, definitely make sure to check it out. I mean, it's for completely free. Where can you go wrong? And you can support the channel this way massively. Put your email address into the link down there, and yeah, then you are basically settled. New news are going to be delivered to your doorstep, and by doorstep I mean your email address each and every morning. Isn't that fantastic? For completely free, support the channel this way. And now we are going to start off with the video. Now the cosine of 3 degrees is a little bit hard to calculate, but we are going to use some very nifty and sexy constructions to actually get rid of the problem of finding this bad boy right here. But at first we are going to decompose the argument a tiny little bit, because you know, if we got a constructible angle right here, and we can express this constructible angle as some kind of difference of other constructible angles, it's also going to be constructible yet again. So what I mean by that is, if we got the cosine of 3 degrees and we are going to rewrite it using the difference of 2 constructible angles, so for example 18 degrees minus 15 degrees, we are also going to end up with a constructible angle yet again. And yeah, this is what we are going to do. And you know what nice thing is? I mean, on the one hand, we can find out those 2 angles very nicely by using constructions, but also there's a difference of arguments formula for our cosine. Namely, you can find a link to the difference formulas down there in the description somewhere. Namely, what we're going to end up with is, let me think for a second. So we got the cosine with the cosine, so cosine of 18 degrees times the cosine of 15 degrees. And in normal case, we are going to subtract the multiplication of the 2 sines, but since we got negative 15 degrees and since the sine is going to be an odd function, we are going to drag negative to the front, giving us a positive sign. So positive the sine of 18 degrees times the sine of 15 degrees. Yeah, I mean, it's looking a bit worse, but it's going to make matters way easier, because now we can find the cosines and sines of 18 and 15 degrees individually, and then by just multiplying those algebraic equations together, etc., we are going to end up with a final exact value for the cosine of 3 degrees, and this is basically our plan. Now let us go ahead and get started with the cosine and sine of 18 degrees respectively by taking a look at a very special right triangle, you could say. Namely, we're going to construct ourselves this triangle right here. It's going to be a right triangle, as mentioned before. Here's our right angle. We are just going to call this side length down here S and this one right here T. And our angle of 18 degrees is going to be up here in the corner. Now we can start adding some angles together, inner angles, interior angles. So we got 90 and then we got 18 giving us 108, meaning we still need 72 degrees down here to get our full 180. Now, this right here is actually a very nice construction, because we can actually find out what the sine and cosine of 18 degrees is by just taking a look at the side lengths here. What I mean by that is, if you just remember the definition of the sine and the cosine in right triangles, then we get that the cosine is nothing other, so the cosine of 18 degrees, so just our adjacent, so t divided by the hypotenuse. And why not make it very easy for us and say that the hypotenuse is 1, because then we have t over 1, which is nothing other than t, being equal to the cosine of 18 degrees. Yeah, and it's that easy. By the same construction we get that s over 1, or in other words s, is nothing other than the sine of 18 degrees. And if we were to find out what s and t are, then we also got our cosine and sine values algebraically. Very nice construction, right? And now we are going to do something that is often used in elementary geometry and what I use too when finding out areas, for example, of triangles in class, in just regular school. Namely, we are going to duplicate this triangle, turn it around a bit and glue it to the same triangle here, giving us, if we just take it times 2, this triangle, and we are going to glue it to here. Then I want you guys to notice that right here, our height is going to be our t. We don't need to draw this in. This side length is 1. Since it's an exact copy, it's also going to be 1. Down here, what we got is just 2 times s. Okay, so we doubled our side length. And other than that, just by taking a look at the angles that we got before, we got 72 degrees down here. What we got up here is going to be 18 degrees, but times 2 this time. Okay, meaning t in this triangle, the side is going to be our angle bisected 2. So this is going to be 36 degrees. And down here, if we add the angles together once again, let me see for a second, this is going to give us 180. Hey, 72 degrees. That's a very nice triangle. This is what you call an isosceles triangle, am I right? I mean, we got 2 side lengths which have the same length overall, and the angles which are at the ends of our 2 equal side lengths are going to be equal to. That's an isosceles triangle. And isosceles triangles sometimes have very, very nice properties when it comes to angle bisecting in them. And this is what we are going to do now. Namely, we are going to take a look at the 72-degree angle and we are going to bisect this angle. Angle bisector means we are just going to cut it in half, you could say. Namely, we are going to end up with 2 ends which are both 36 degrees Celsius, not Fahrenheit. Now, speaking of 36 degrees, this is also kind of curious, am I right? I mean, we got 36 degrees here, 36 degrees down here now in this triangle, meaning overall, this triangle that we got here, that's also once again isosceles triangle by definition. And this is really cool because now we got the base here, so we got 2 equal angles here, meaning this side length here and this side length here are going to be exactly the same once again. But this is not the only isosceles triangle that we got now by bisecting the angle. Namely, we got 36 degrees here, we got 72 degrees here. Let me enlarge this a tiny little bit. Okay, we are going to have the by rotating it a bit, we got 72 degrees here, like mentioned, by angle bisecting, we got 36 degrees here, and that's exactly the same situation that we got here. If we add those together, 108, missing just 72 degrees. Meaning, what we got here is also an isosceles triangle. But the cool thing about this isosceles triangle is the fact that the 72 degrees angles right here are both here, okay, this is also 72 degrees, meaning those two side lengths must also be equal. Meaning our angle bisected that we got here is also 2s lengths long. Meaning, if we put this into here, this is 2s, this is 2s. And now we also know that this up here is going to be an isosceles triangle once again. Meaning, this side length is equal to this one, 2s, meaning the side length that we got down here is just a difference of 1 and 2s, because if we just take 2s away from 1, we are going to get this side length down here, which is exactly this side length. That's a very cool construction, right? I mean, this is pretty ingenious if you ask me. So 1 minus 2s is going to be this side length down here. And now we can start solving for s, for example, and then just the answer for t is going to fall completely from the sky very trivially, because we can make use of Papa Pythagoras in the right triangle by construction. Very cool, am I right? This is so thick. That's a very thick individual. Now, I mean, how can we find out our s's here? I want you guys to notice something. We got two triangles with the same inner angles, but different kind of side lengths. This is what you call similar triangles. And the cool thing about similar triangles is that the side lengths share the same ratio. So 2s divided by 1 has the same ratio as 1 minus 2s divided by 2s. I mean, it does make sense. If this triangle, for example, is scaled up by a factor of 2, then this side length right here is, for example, 1/2, and this one right here is going to be 1. Meaning, just the ratio on both side lengths is going to be equal. So if we scale this up to right here, then if we have s being equal to 1/4, for example, we got 1/4 here, and down here we got less, okay? I don't know, mental arithmetic. But I hope you see where I'm going at here. The ratios must be equal because those are similar triangles. Meaning how we can formulate this is that 2s divided by 1, which is just 2s, is hence nothing other than, okay, and now this ratio is 1 minus 2s on the base, divided by this base, 2s. Now we can just start solving for s up here, very trivially. We can multiply both sides by 2s because it's not equal to 0. S is the side length, hence it's strictly positive, meaning 4s squared is going to be 1 minus 2s. And now we can bring everything to the left-hand side, for example, giving us overall, and dividing by 4. 4 is not equal to 0 because it's a successor of 3, giving us overall s squared. And now let me think, plus 1/2 s, and then negative 1/4 is equal to 0. And this right here just screams for the quadratic formula, letting us solve for s in the process. Meaning our s is going to be equal to, okay, let us see. We are going to get negative, okay, we are going to get 1/4 here. Plus or minus the square root of. Now we are going to take the 1/4 and we are going to square it, so giving us 1/16. And now we are going to add 1/4 to it, plus 1/4, 1/4. Okay, this is all nice and fine. We can expand this right here by 4, taking the square root of 1 over 16, or yeah, just basically the 16 in the denominator, giving us negative 1/4 plus or minus, and then we got 1/4 times the square root of, okay, if we expand this, we got 4 plus 1 in the same denominator, giving us 5. And now we just need to see which branch we need to take. I mean, s is a side length. It's defined positive in some way, meaning we need a positive answer. Since square root of 5 is also going to be positive, and square root of 5 over 4 is hence going to be bigger than 1/4 that we got here, we need to take the principal branch, so the positive branch. Otherwise, with negative branch, it would be a negative answer, obviously, because we get, just negative answer overall. So by only choosing the positive branch, we are going to get s, which is by definition nothing other than the sine of 18 degrees. To be equal to, and now we are going to get, we get 1/4 as the common denominator. We are going to get positive square root of 5 minus 1. And this right here is the sine of 18 degrees. Pretty nice answer, right? And now that we are done with that, we can go ahead and get started finding the cosine of 18 degrees by using Papa Pythagoras. Meaning, in this right triangle that we got here, we also know that Pythagoras tells us that t is nothing other than the square root of the hypotenuse, so 1 minus s squared. If we now take a look at s squared, we are going to get that this is the square root of 1 minus s is a square root of 5 minus 1 over 4, so we get something over 16. And if we were to square this term, we are going to get, okay, square root of 5 squared, which is 5, and then we are going to get positive 1, which is going to give us 6, and in the middle we are going to get negative 2 times square root of 5. So 6 minus 2 times square root of 5. Yeah, meaning by expanding just to 1 by 16 over 16, we get 16 minus 6, which is 10. Negative and negative becomes positive, meaning overall that our t, which is going to be nothing other than the cosine of 18 degrees, is going to be equal to the square root of 10 plus 2 times the square root of 5 over 16, and both numerator and denominator both share a factor of 2 because 10 is 2 times 5, giving us overall that the value of the cosine of 18 degrees is the square root of 5 plus square root of 5 over 8. I mean, you can still factor stuff out, so down here in the denominator what we get is something like 2 times square root of 2, but really this doesn't matter at all for our exact value. Now that we are done calculating the cosine and sine of 18 degrees respectively, we can go ahead and get started to find out what the sine and cosine of 15 degrees are. And for this I would like to take a look at the difference of arguments once again, because there's one value, so the cosine and sine of 45 degrees, which is actually really easy to find. So at first, let us decompose our 15 degrees a tiny little bit. Meaning, we are going to take a look at, for example, the cosine of 15 degrees being equal to, okay, now this right here is the same as the cosine of 45 degrees minus 30 degrees. And once again, by using addition theorems and the like, we are going to get something other out, which we are going to use at the very end. But at first, I would like to take a look at the cosine and the sine of 45 degrees. This is going to be very important and very easy to find out overall for calculating our value of the cosine of 15 degrees. For this, we are going to take a look at the unit circle. Okay, unit circle is just a thing with a radius of 1. And 45 degrees is exactly half of 90 degrees. Meaning, in this exact situation where we got 45 degrees right here, our cosine and sine on the unit circle are going to be exactly the very same. Namely, by this fact right here with the unit circle, okay, you can also calculate it very easily that they have the same values. The cosine of 45 degrees is the same as the sine of 45 degrees. And the easiest way I could come up with to calculate their respective values there is by using Pythagoras once again, namely that the cosine squared of 45 degrees plus the sine squared of 45 degrees is equal to 1. And since they bear the same value, it doesn't matter which we substitute with which. For example, let's go with the cosine being equal to the sine, so subbing the sine into here, we are going to get 2 times the sine squared of 45 degrees is equal to 1. And now we can just start solving for the sine of 45 degrees. By dividing both sides by 2, successor of 1, not equal to 0 obviously, and then taking the positive square root, because 45 degrees is in the positive part of the complex plane right here, meaning overall we are going to get that the sine of 45 degrees is the same as the cosine of 45 degrees, which is going to be the square root of 1/2, which is going to be 1 over the square root of 2. Very important value that you should always have somewhere in your head, okay, on the back side, lying around. I'm using this extensively in integration, for example. And next up, we are going to take a look at some construction to find out what the sine and cosine of 30 degrees actually is. So the construction for the 30-degree angles is going to be very similar to the one we had before. Namely, we are going to take a look at a right triangle. And what we are going to do once again is we are going to say hypotenuse is equal to 1. Right triangle, we are going to have our 30 degrees up here. And we are going to say that S and T are going to be our side lengths yet again, with the connection that we get S is equal to the sine of 30 degrees yet again, and T is equal to the cosine of 30 degrees. And now let us take a look at the interior angles once again. I mean, we got 90 degrees, 30 degrees, 120, giving us 180 if we have an angle of 60 degrees down here. And I can't stop smiling yet again, because this construction is once again very nice. Same thing as before, we are going to duplicate our geometric structure and glue it to the one that we have. right here. Meaning if we were to duplicate this, okay, oh, this is such a nice triangle, we're going to get the double of 30 degrees up here, 60 degrees. Now we got a 60-degree angle here, and oh, what do we have down here? Oh, this is once again a 60-degree angle. Isn't that nice? That's a very cool triangle if you ask me. Now what we got down here is 2s, and we got one up here and one up here. Now, what is this triangle that we got here? We got 3 interior angles which are the same. This overall means that this right here is an equilateral triangle. One of the words I hate the most in the English language. Equilateral triangle means that all 3 side lengths also must be equal. There's no way around it. Meaning, we can also conclude what s is. Since 2s must be equal to 1, we know that s must be equal to 1/2, meaning the sine of 30 degrees is equal to 1/2. Oh, this is such a great construction. I love it. And once again, by using Papa Pythagoras, the value for t is also going to follow completely trivially. Namely, we know that t is once again the square root of 1 minus s squared, which is going to be just the square root of 1 minus 1/4. 1 minus 1/4 is 3/4, leaving us overall with a value for the cosine of 30 degrees being equal to just the square root of 3/2. That was so easy. I love it. I love it. This is just ridiculously nice. And yeah, now we just need to take a look at the addition theorem once again that I was talking about, because we actually take a look at the cosine and the sine of 15 degrees, and then we are basically done by just plugging the last values in. Let's take a look at the addition theorem for the cosine of 15 degrees once again. I mean, this is the cosine of 45 minus and then 30 degrees, meaning by using the same addition theorem that we got here, just with different angles, we're going to get out that this is the cosine of 45 degrees times the cosine of 30 degrees plus the sine of 45 degrees times the sine of 30 degrees. And now we can just start plugging our values in. I mean, cosine and sine are completely equal on 45 degrees, so 1 over square root of 2. Cosine of 30 degrees is, by what we found out, square root of 3/2. And now we got plus 1 over square root of 2 times, and sine of 30 degrees is 1/2, what we just found out. Meaning what we got is the same denominator, 1 over square root of 2. 2 square root of 2, I'm terribly sorry, 1 over 2 square root of 2. And what we get up here by using the distributive laws or just adding fractions together basically is going to be 1 plus the square root of 3. Very nice, right? Very, very cool. And now we can go by the same logic and find out what the sine of 15 degrees is. Sine of 15 degrees by using the addition theorem is going to be, let me think for a second, so we get sine of A, so we get sine of 45 degrees, I hope I'm not getting this wrong, this is the imaginary part times the cosine of 30 degrees. And this time we are going to get negative sine because of the negative 30 degrees that we get by using the difference here, meaning we are going to get negative the counterpart basically, so sine of 30 degrees times the cosine of 45 degrees. Yeah, and now we are basically done by just plugging the values in yet again. I mean, this right here is 1 over square root of 2. Then we get a cosine of 30 degrees, which is going to be the square root of 3/2. Other than that, we get negative 1 over square root of 2. And once again, just 1/2, which is the sine of 30 degrees. Meaning overall, we get a common denominator of 1 over 2 times square root of 2. Once again, 2 times square root of 2. And then we get square root of 3 minus 1. I hope I got everything correct here with the addition theorem. And now we are basically done. We can just start plugging our values in. So we now found out what cosine and sine of 15 degrees are. We know what the cosine and sine of 18 degrees are. So meaning overall, we now know that the cosine of 3 degrees is going to bear this very, very ugly expression. Namely, we're going to get the cosine of 18 degrees. This was by what we found out, square root of 5 plus square root of 5, everything in square roots, and all of this divided by 8, and this multiplied with the cosine of 15 degrees, and the cosine of 15 degrees is going to be 1 plus the square root of 3 over 2 times the square root of 2. And now we are going to add to it the sine of 18 degrees. Sine of 18 degrees is square root of 5 minus 1 over 4. and then we are going to multiply it with our sine of 15 degrees, which is the square root of 3 minus 1 over 2 times square root of 2. And there is probably something that you can do to simplify this further, finding out, I don't know, common denominator of, what is the common denominator? I mean, we got 2 times square root of 2 here on both, but we could expand this with square root of 2, meaning we got a 4 here, yes, 16 is probably the common denominator, something like this, but this really doesn't matter. This right here is a perfectly fine, accurate, exact value for our cosine of 3 degrees, and now I leave it as an exercise to the reader to find out what the sine of 3 degrees is. Just a little hint, make use of the sine addition theorem and just the values that we found out before. And this basically concludes today's video, and if you did enjoy what you saw today, definitely make sure to check out Daily Peanut, today's sponsor. They were kind enough to sponsor this video, and even though it's not something I talk about too much, news and the whole wide world, politics, etc., it's your way to find out about these topics using their content. Other than that, don't forget to check out STEMRich EU 2. Would mean the world to me if you could just give it a shot, check it out, and maybe there's something in stock for you that you would like. And other than that, I thank you guys for watching. Please stay safe, and up until the next video, you guys have Flammy day. It's so hot here in Germany. Ciao.